Professor Bob Young back at you here, and we've been talking about graphing and common functions and stuff, so we're going to look at what's called piecewise defined functions in this video, some step functions, and the relation x equals y squared, which is not a function at all. So we're going to go ahead and graph some what's called piecewise functions, and here's what they tend to look like. They've got f of x or y equals negative 2x plus 5, and notice there's restrictions on these equations. So for the y equals negative 2x plus 5, the x values must be less than or equal to 2. On the y equals x plus 1 graph, x values must be greater than 2. So these are what's called restrictions on each graph. And hopefully you would know from previous videos, if this is y equals x to the first power in both of these cases, you would have graphs of lines if we were going to graph these entire creatures, and actually these would be graphs of lines in slope-intercept form. All right? But we're only going to see a piece of the line because of these restrictions, thusly named piecewise functions. And in the second example, we're going to graph y equals 2x squared plus 3 when x is less than or equal to 1, just to take some different restrictions, and y equals negative x plus 6 when x is greater than 1. So let's go ahead and continue the discussion here. And what I like to do, and this is what the graph's going to end up looking like here, is I like to, when I teach students how to do piecewise functions, is just take the two graphs and break them into the first piece, which is y equals negative 2x plus 5, and then the second piece, which is y equals x plus 1. And I like to tell students to go ahead and make a table of values for each piece, thusly named piecewise functions. All right? Now notice on the first piece here, the x values must be less than or equal to 2. So I'm going to start with 2. I'm going to put in 1 and 0 here. So if I plug in 2 for x, y would be 2 times negative 2 would be negative 4 plus 5 would be 1. If I put in 1 for x, I would get 2 times negative 1 would be negative 2 plus 5 would be 3. And if I put 0 in for x, negative 2 times 0, 0 plus 5 would be 5. So let's go ahead and plot these points here. So 2, 1, that one's already plotted. Now notice this is a closed circle on this piece. And it's a closed circle, and I'm going to go ahead and do this in red because 2 is included in this first piece because it's got the less than or equal symbol. So when you see that, it's going to have a closed circle which contains when x is 2. So there's a good point to be made there. Get it? Point to be made. All right, 1, 3. You won't get that on the Math Excel videos or other videos, the old Young sense of humor. Some of you are going, I'm glad of that, all right. And then 0, 5 would be here. So notice we could connect the dots, and all values less than or equal to 2 would shoot that direction. Now let's do the second piece here, and I'll go to another color. You know I like to use these different colors. Now notice on y equals x plus 1, our x values have to be greater than 2, but I want you to start at 2. Sometimes students see that greater than 2, and they put 3 there or 4 there first. They go, Young, it can't be 2, it can't be 2, but you must get all the values between 2 and 3. See, so we're going to pick values greater than 2, so we'll pick 2, 3, and 4. So if I put 2 in for the second piece here, y equals x plus 1, 2 plus 1 is 3. If I put 3 in, 3 plus 1, 4, so you can see the point, getting the points isn't real difficult when you graph. 4 plus 1, 5 here. Now notice on this second piece, we've got an open circle on 2. Okay, now that's because x does not include 2 here, so that is why if it's just got the greater or less than symbol, open. And then if we plot the other points, 3, 4 will be about right here, 4, 5, And you can see the second piece shoots off this direction. Now, can y'all tell me why this is the graph of a function? If you run a vertical line across there, especially in this middle part at 2 there, see, it can never cross in more than one point. So be careful there. All right, now for the second example, we're going to have 2 pieces here. Now, hopefully you recognize this first equation, y equals 2x squared plus 3, with the y equals x squared there as a parabola. All right, so I'm going to go ahead and put first piece. This one I'm going to write out first piece, second piece. And I'm going to put in y for the first piece equals 2x squared plus 3, and I'm going to make a little table of values. And then I'm going to put in y equals negative x plus 6 for the second piece, and table of values here. And we're going to go from there. Now, if I put in, now for both of these, look at the restricted number on both is 1. So I always tell students in both pieces, always put that number first, 1. All right? So I'm going to start with the parabola here. Now on the parabola, the top part, it has to be values for x less than or equal to 1. So I'm going to put in 1, 0, negative 1, and so forth. And I'm going to, when I put 1 in for x, I'm going to get 2 times 1 squared plus 3, y would be 5. If I put 0 in for x, I would get 2 times 0 squared would be 0, plus 3 would be 3. If I put negative 1 in for x, I would get 2 times negative 1 squared would be 2, plus 3 is 5. So let's plot those points here, the first piece. And I kind of left part of this one out. So I'm going to go 1, 5 would be a closed circle there. 0, 3 would go this direction. So I'm taking values less than that. Negative 1, 5 would be here. And you can hear my puppy, Lucky. We have a 10-month-old puppy barking in the background, so you never know what you get on these videos. Lucky sees someone out front there, and he's not a happy camper. And when I connect the dots here, and I'm trying to connect them, my board's kind of going a little crazy here, I get a piece of a parabola for all x values less than or equal to 1. All right, so that's the first piece. The second piece, I have to have x values greater than 1, so I'm going to put in 1, 2, 3, and hopefully you all know this would be the graph of a line. Now, when x is 1, we get negative 1 plus 6. See, we land on the same point there. So if these didn't overlap, if these were somewhere else, this line would have an open circle there. See, but the parabola already made it closed. But these two overlap, so we kind of got the closed circle on top of the open one. Does that bother y'all out there? Sorry. All right, now for the rest of the line, we have to pick x values greater than 1. So if I put 2 in, negative 2 plus 6 will be 4. If I put 3 in for x, I get negative 3 plus 6 would be 3. And here you can see if we just plotted a few more points here, we only need 1 for a line, that we would have the line going kind of downward that direction. Again, it's a function because no matter where I run a vertical line, it will never cut the graph, even of a piecewise function, in more than one spot. And then they might start messing with you on evaluating functions here. So let me go ahead just for fun here. What if they said, Young, what is f evaluated at negative 2? In other words, if I take negative 2 and plug it in for x, which piece would I plug the negative 2 in, the top or bottom? And again, it's these restrictions here. Since the top piece is for all x values less than or equal to 1, you would take the negative 2 and plug it in there. And you would evaluate the function. So negative 2 squared would be positive 4. You'd get 2 times 4 plus 3. So when x is negative 2 in this piecewise function, y would be 11. Or if I said f of 8, you would have to plug it in the bottom piece. That's where x numbers are greater than 1. See, so if you plug in 8 for x, you'd have to plug it in the bottom piece and get negative 8 plus 6 would give us negative 2. So you can even evaluate functions with these. Now, I'm not going to put any of these on the test. I am going to cover it on this video. It's called the greatest integer function, and it looks like it has a few brackets on each x. And what that means is the greatest integer function pairs every real number x to the greatest integer less than or equal to x. Now, integers are counting numbers, whether there be positive, negative, or 0. So whenever I'm teaching the greatest integer function, these are integers, no fractions, no decimals, forever and ever and ever, both directions. All right, now notice the greatest integer thing. This is also called the step function here. They give us some values for x and y, and those are certainly correct and so forth. But I want to focus in on this step that's down here, right next on the x-axis. So here's what they mean if I'm going ahead and plugging in points. If I let x be 0, the greatest integer less than or equal to 0 is 0. Let's say I put in 0.1 for x. The greatest integer less than or equal to 0.1 is still 0. That's why they call it the greatest integer function. What if I point in 0.3? 0. 0.7? 0. 9/10? 0. 999 over 1,000, 0. So the greatest integer, when you plug a value in for x, it's the greatest integer less than or equal to that. So this is the first step here. Now notice when x goes to 1, y goes to 1, and then we're up here. This is why they call it the step function. All right. Now what I tell students to do is whenever you see this, whenever you see the greatest integer function, just go ahead and let x be between, or whatever's in there, between 0 and 1. There is my puppy Lucky again barking, so you'll have to get used to hearing him in the background sometimes. He is the defender of home. I'm going to have to start doing more of these at work. Lucky, that's okay. That's all right. All right. So that is what the step function looks like. And notice it's a function because you have a closed circle on top of each open circle. Now again, to cheat on this, here's how I'm going to show you to cheat, is always get this first step along the x-axis. And here's how I'm going to tell you to cheat. All right, I'm going to take 1/2 x plus 1, and I'm going to put it between 0 and 1. Notice it can equal 0, but it can't equal 1. And I always tell students, get that first step and then cheat on all the rest of them. I know what you're saying, Young, you shouldn't tell us to cheat. You're a professor sworn by honesty and all that's righteous and so forth. I know, I'm sorry. All right, so when you do this, you kind of get a tweener there back from earlier lessons, and you get -1 is less than or equal to 1/2 x is less than 0. So we're going to multiply through by the LCD of 2 to get x by itself. So that first step, we're going to have x is between -2, which includes -2, and 0. And you see that first step right there? You've got closed and you've got open there. So that is the greatest integer function. And then once you get that, see, you can go up right over the closed circle, put an open circle, go over to closed, and you can keep cheating, keep going up one, each one, and getting closed. So I always say, get the first step on these. Now, I don't think I'm going to give you a whole lot of these in the homework or on the test or anything like that. I just did it in case you ever see it in statistics and need it for something else, or maybe in pre-calculus. So I'm just doing a real quickie on that. Get the first step. Take whatever's in there and put it between 0, including 0, less than 1, and that'll always give you integer values. Now, here's an application of the greatest integer function. You can actually use these step functions in real life. I know when I was a teacher, we used to get these step increases, you know, an extra $20 a year or something, but you don't get into teaching for the money. But anyway, it says an express mail company charges $25 for a package weighing up to 2 pounds. For each additional pound or fraction of a pound there is an additional charge of $3. So we're going to let D of X represent the cost to send a package weighing X pounds and graph Y equals D of X in the interval 0 to 6. So notice here, for X in the interval from 0 to 2, Y is 25. For 2 to 3, we got the step there, add 3, 28. For 3 to 4, 31, and so on. So that is how some businesses would apply the step function. And even like I said, teachers, we used to have steps and increments, and some still do in some parts of the state and nation. Okay, and lastly here, let's look at the relation X equals Y squared. Now notice this is not, it says recall that a function is a relation where every domain or X value is paired with one and only one range value. Now notice here, the X's would be cheating, or they would repeat. See, because if you say X is 1, you get two values of Y. So when X is, if I make a little table over here and emphasize this, when X is 1, Y could be 1, or it could be -1, which makes it fail the vertical line test, and you would not have a function, but it is still a relation. And it still has a domain, and the domain, the X values go from 0 to infinity. Now the range on Y, this thing's going to keep opening that way, and it's going to keep opening that way forever and ever. So the range would be from -infinity to infinity. All right, so Bob Young signing off. Keep hitting those Math Excel problems, and now hit that homework.